Lesson 72, Implied Ratios. Okay, so for this lesson, we are going to be using ratio boxes, but we're going to change them up a little bit. So it should look pretty familiar, but you're going to be labeling things a little different. Okay? If 12 math books weighed 40 pounds, how much would 30 math books weigh? So I'm going to draw what we've been calling a ratio box. And normally we would label our two rows. One is R and one is A, right? We're going to label these differently this time. And we're going to label these case 1 and case 2. Because there isn't really a ratio that they give us on here, we're implying that there's a ratio. We're working on this, imagining that the relationship between the numbers stays the same, even though it doesn't specifically tell us that. So here's our books, and here is our pounds. And in the first case, it says 12 math books weighed 40 pounds. Oops. So I have 12 books, 40 pounds. So that is case 1. But there's a second set of books that I'm comparing with this. It says I have 30 math. How much would 30 math books weigh? And that's going to be case 2. So I don't know the pounds, but I do know how many books I have. I have 30. So then I can put a P for pounds here. And this should look pretty familiar. This should look a lot like the ratio boxes we've been doing. Now to find P, I'm going to have to do fractions where I cross multiply. So I'm going to take my numbers and make them into fractions. I can simplify before I cross multiply, or I can just go ahead and cross multiply. So 12 and 40 are both divisible by 4. So 3/10. So now I have 3/10 equals 30p. So now I'm going to cross multiply. So I have 3p equals 300. So to get rid of my 3, I'm going to divide both sides by 3. Which gives me p equals 300 divided by 3, right? And that's going to give me 100. And I need to have a label, pounds. Okay, so I'm going to put my 100 here. Does that make sense? This is 12 fits into 40 about 3 times. 30 fits into 100 about 3 times. So this is an answer that I would expect to be. Okay, so example 1. If 5 pencils cost $1.20, how much would 12 pencils cost? Use a ratio box. So here's my ratio box, and I'm going to label this as case 1 and case 2, because they don't actually give us an actual ratio, but we're assuming the relationship between the numbers is the same. So thinking about pencils, I'm going to say that this is pencils and this is dollars. And I have 2 different sets of numbers. My first set is 5 pencils is 120. We're going to label that as case 1. And my second set is 12 pencils, and that's going to be case 2. And I don't know all of case 2. I'm trying to find out another number in case 2. So I'm going to go ahead and fill in my numbers. So I have 5 pencils cost 120. And I can just drop that 0, or I can leave it. It's your choice. But since you're multiplying, it's probably easier to drop it for right now. And then case 2 is 12 pencils. And I don't know how much my 12 pencils cost, so I'm going to put a D for dollars down here. Now what I need to do is make these numbers into fractions. I can't simplify my fractions, so I can go ahead and cross multiply. And I get 5p equals 1.2 times 12. I want to go ahead and simplify the other side first. So 1.2 times 12 is going to give me 1. 14.4. And I can find that by doing 12 times 12, which gives me 144, and then moving my decimal one place, because I have one decimal I'm multiplying by. But I still have this 5p over here. So I need to I need to divide both sides by the same amount to get rid of the p. So I'm going to write down here so I have a little bit more room. I'm going to divide both sides by 5. And p equals 14.4 divided by 5, so I need to figure out what that would be. This fits in 2 times. That fits in 8 times. And 44, sorry, that's a 4. Bring down a 0. So it should be about $2.88. Okay, so my dollars here is $2.88 is how much it's going to cost for me to have 12 pencils. And that makes sense because 5 is to, let's say this is 12, okay? 5 to 12 is about times 2, right? Because 5 times 2 is 10, so it's a little bit more. So 12 times about 2 should give us a little bit more than 24. So this is about 28. So I would say this is a reasonable answer. Example 2. Mrs. Campbell can tie 25 bows in 3 minutes. At that rate, which means I'm doing a ratio box most likely, how many bows can she tie in an hour? So I go ahead and set up my ratio box, but we're going to use case 1, case 2, because it doesn't give us an actual ratio. Okay. Gives me 2 sets of numbers. First set is 25 bows in 3 minutes. That's case 1. And then case 2, how many bows can she tie in an hour? That is the only information it gives us for case 2, but I want to make sure I'm using the same numbers or the same units. So I'm going to use minutes, even though it says hour. How many minutes is in an hour? Well, 60 minutes is in an hour. Okay, and that's what I'm going to use for case 2. So she does bows per minute. 25 bows in 3 minutes is case 1. Case 2, I don't know how many bows she can tie, but I know it's asking me in 1 hour, which is the same as 60 minutes. If you put a 1 where I put this 60, you're not using the same units. It's not going to be the same relationship. It's going to mess up your numbers. Make sure you're putting it in minutes. All right, next thing I do is make some cool looking fractions. Okay, and I go ahead and cross multiply. Sorry. So 25 times 60 equals 3b. So what I can do is do 25 times 6 and then add a 0 at the end. So, because there's a 0 here, right? 5 times 6 is 30. 2 times 6 is 12 plus 3 is 1500. Equals 3b. So now I need to divide both sides by 3 to get the b by itself. So I end up with 1500 divided by 3 equals b. 1500 divided by 3 gives me 500 equals b. I can't just leave it like that, though. I need to have a label, so I can say 500 bows. And I need to check to make sure that this is reasonable. So 3 and 60, so it needs to be a big number compared to my original number. So 25 is a small number, 500 is a big number, so I would say that that is a reasonable answer. So 500 bows. And our last example for this problem. or sorry, lesson. So 6 is to 15 as 9 is to what number? So this is really an analogy using math. So I'm going to do my ratio box with my cases again. Okay. And then the label's a little bit weird here. I'm going to just do first number is to second number. And a lot of you are going to be able to look at this and already know what the relationship is, but go ahead and show your work on this. It will help you later, okay? So case 1 is 6 is to 15. Case 2 is 9, and we don't know what the second number is. So 6, 15, 9, N for number. And now I'm going to go ahead and write myself a nice little equation down here. And I can simplify this and say, well, 6 and 15 both have a 3 in them, so this can be 2 and a 5. 2/5 equals 9n. And now I'm going to cross multiply. So I get 2n equals 9 times 5. 2n equals 45. I need to get rid of this 2 on next to my n, so I have to do the same thing to both sides. Divide both sides by 2. Cancels out over there. N equals 45 divided by 2, which is 22 and a half, or you can do 22.5. So 22.5. Okay, so that is the examples. Go ahead and do your 3 practice set problems and then check your work with the video. All right, I hope you did your practice set, and now we're going to check your answers. So Kevin rode 30 kilometers in 2 hours. At that rate, how long would it take him to ride 75 kilometers? Estimate answer, then use a case 1, case 2 ratio box to solve. Okay, so first I have 2 things to do. Estimate and then use box. So if I'm estimating, it took him 2 hours to ride 30 kilometers. So how long would it take him to ride 75? So 30 kilometers in 2 hours. So 75 is a little bit more than twice 30, right? So twice 30 is 6 kilometers. So I'd say 6 kilometers in 4 hours. So maybe 5 hours would be a good estimate then, because I still need to go 15 more kilometers. So let's see what we get. Okay. Ratio box, case 1, case 2. And I look at my numbers. It says 30 kilometers in 2 hours. It's going to be case 1. And case 2 is 75 kilometers. It doesn't tell us if he's riding, like what he's riding though. I want to know, like, is he riding a horse? Is he riding a donkey? Is he riding a bicycle? Is he riding a surfboard? Like, there's a lot of questions that are not answered, unfortunately. So it says he rode, so can we put let's do kilometers here, and then hours is over here, right? So 30 kilometers in 2 hours. And our second one is 75 kilometers. Each is hours. Do some nifty fractions. 30 over 2 equals 75 over h. Know right away that I can simplify that because 30 fits into 2 perfectly. So I can cross multiply now. So 75 times 1 is 75. 15h. Divide both sides by 15. This cancels out. And now I have 75 divided by 15, which gives me 5 equals h, so 5 hours. So I'm so brilliant. Look at my estimation is exactly the right answer. What you have to understand though on a problem like this is you're assuming the relationship stays constant. In real life, if he is biking or riding a horse for this amount of time, you can assume that the pace will change. What if he comes to a river and has to ford the river? What if he gets tired? He's going to go at a different rate. So just keep that in the back of your mind, that sometimes with math, we're implying a ratio, but it doesn't always fit in real life. Okay, if 6 bales are needed to feed 40 head of cattle, how many bales are needed to feed 50 head of cattle? So I make my ratio box and think about how strange it is that we say head of cattle, but that's what we do. Case 1, case 2. This is our cattle. Cattle are cows, if you don't know that. But you live in Missouri, so you probably do. And let's see. 6 bales for 40 heads is my first case. And then my second case is my 50 heads. Oops, sorry. Didn't get to do my highlighting here. Love the highlighting. It makes it so pretty. So I might have written this backwards to how you wrote it. So let me make this the way you probably wrote it. Frustration. Okay. So we're going to do bales to cattle. Now, could I have left it the other way? Yes. As long as I make sure my numbers are in the right spot, it doesn't matter which order I write them in. I'm just trying to make sure it's as close to what you did as possible so it's easier for you. So that's case 1 is 60-40 and 50 cattle's over here. I don't know the number of bales though. Okay, bales is like bales of hay. So how much would I need to feed them? So then I make my fractions. I can simplify this guy and take out 2 from both of them. So it's going to be 3/20. So 3/20 equals b over 50. Cross multiply. 3 times 50 is 150. 20 is times b. Okay, so now I need to divide both sides by 20. And that's going to give me, cancel these guys out, 15 divided by 2 is 7.5 equals b. So it's going to be 7.5 bales would be how much I would need for 50 head of cattle. And you know, that's a reasonable answer because 60-40, this isn't much higher of a number, 50. So I would expect it to be not much more than 6, but higher than 6. So this is a reasonable answer. So 7.5 bales is letter B. All right, last one is an analogy. So I'm going to go ahead and do my ratio box with my case 1 and case 2. Okay. Remember that I label these as first number, second number. And this is proportions of numbers to each other. So if 5 is to 15, is case 1, as 9 is to what number? So 5, 15, 9, what number? Ooh, I don't know. 5 over 15 equals 9 over n. Made fractions out of my ratio box. I simplify. And now I cross multiply. So 1/3 equals 9 over n. Cross multiply. 1 times n equals 3 times 9. Ooh, I really don't need to do anything on that side. That's exciting. So I just end up with 27. Does that make sense? 5 times 15 is, or 5 times something is 15. That's 3. 9 times 3 is 27. That makes complete sense. I like that answer.